So if you work in or, around technology today, you definitely know the struggle.
Yeah, yeah.
The information fire hose is just, it's constantly on. And trying to stay relevant feels less like a career path and more like just digital survival.
That feeling of overload is
Mm.
completely justified. I mean, the rate of change in software, in data, in AI, it has totally fractured the traditional engineering role.
It really has.
And that's why we've distilled a huge amount of planning into a really precise guide. We're basing this on the 2026 Tech Roadmap, Essential Skills for Success.
And our mission in this deep dive is really to give you that shortcut to clarity. We're going to function as your guides, mapping out the 10 core skill areas that, truly power modern systems. We want you to walk away knowing what these skills are and, more importantly, how they all relate to each other, how they stack up.
We are essentially mapping the entire set of competencies you need. I mean, this is the foundation required to build, operate, and crucially secure intelligent products for the next few years. And this isn't just a list of buzzwords. It's a structural guide to the engineering mindset of 2026.
And the source material organizes this so well. We'll start with the strategic foundation, the thing that guides all the technical work.
Yep.
Then we'll move through the core architecture, the specialized layers like data and AI, and then finally, how to keep the whole engine running and secure.
So let's begin where the roadmap says every major project has to start. And it's not with code, it's with human judgment.
Okay, let's unpack this. Starting with the skill that really dictates the success of all the others.
The foundational skill, the one that guides everything else, is product and technical decision-making.
Okay.
And the roadmap makes this compelling case that this is the most critical starting point because it forces you to choose architectures and trade-offs that directly match business goals.
So it's not just about the best tech, it's about the right tech for the business need.
Exactly. If the business needs speed over, say, absolute consistency or cost control over maximum performance, that decision has to be made right here at the start.
Wow, so that completely reframes the role. I mean, the engineer isn't just a coder anymore. They're, like a risk portfolio manager for the whole company?
That's a great way to put it. A risk manager.
So how does the source get into, the practical application of that skill?
It's highly focused on measurable outcomes. So rigorously tracking cost and performance metrics to make sure you're profitable, planning proactively for reliability.
Proactively, not reactively.
Right. And continuously managing risk. But here's the key part. It's also about managing priorities and strategically addressing technical debt, that complexity we all build up over time.
And the insight there is that technical debt isn't just some messy code, right? It's an active business risk you have to budget for.
Exactly. If you don't master this first step, you could end up perfectly building the wrong thing.
Which happens all the time.
It happens all the time. This is about building smartly in alignment with the business.
Okay. So once we have that strategy sorted, we move into the actual engineering fundamentals. If product decision-making is the brain, this next part is like the muscular skeleton of the system.
That brings us to skill number 2, back-end engineering. This is the essential foundational building block. Every other skill we're going to talk about builds on the ability to create robust, fast services.
And this covers the absolute core components, but with a modern focus, I'm guessing?
Oh, absolutely. We're talking about building robust, well-documented APIs.
The language of the internet, basically.
Right. And then managing transactional databases, implementing smart caching for high read loads, developing microservices.
And authentication, all that good stuff.
All of that. Yeah. But the really critical piece, and the source highlights this, is incorporating observability hooks.
That observability component is it's huge today, isn't it? It's not enough to know the service is on. You need to know how it's running.
Precisely. Observability means performance tuning, logging, tracing.
Wait.
It's all built in from day one. You can't wait for a failure to try and debug a black box.
Right. So once we have that foundational service built, the next big hurdle is scale. We have to make sure it doesn't fall over when 1 million users show up.
Which connects us perfectly to system design mastery.
Okay.
What's really interesting here is that system design is basically the skill of proactively anticipating failure. It's all about high-level reliability and horizontal scaling.
So what are the fundamental tools or levers the source points to for getting that kind of stability?
We're talking about sophisticated patterns like using load balancing to spread traffic out.
Standard stuff.
Right. But also strategic caching with things like CDNs and implementing queues for asynchronous tasks. And then it gets into the weeds with data persistence, things like sharding the database.
Breaking it into smaller chunks.
Exactly. and setting up replication for fault tolerance.
Okay, so sharding, replication, caching, that's all about speed and uptime. And that brings us to this concept of the consistency trade-off. This is often a real aha moment for people. Can we nail down a real-world example of that?
Oh, definitely. Think about a social media feed or the comment section on a huge global site.
Okay.
If you replicate that comment data across hundreds of servers globally, you get incredible speed and availability for everyone. But if I post a comment here in New York, it might take a few seconds to sync up with the server in Singapore.
Which means a user in Singapore might see a slightly older version of the feed for a moment.
Exactly. You are trading what's called strong consistency, where everyone sees the absolute latest version immediately for eventual consistency, where the data will sync up pretty quick.
I see.
System design mastery is knowing when to make that trade-off. A comment feed can handle it. Your bank balance, absolutely not.
That makes perfect sense. And that kind of global scale, it really only operates in one environment today.
Which is why the next essential skill is cloud architecture. This is all about designing scalable, secure systems specifically in the public cloud.
And the source material is really clear that, platform lock-in is a big risk. You need to be familiar with AWS, Azure, and GCP, even if you only use one primarily.
100%. The specifics here are the building blocks of the cloud. So, sophisticated networking, managing compute resources, storage strategies, and especially leveraging serverless computing for efficiency.
And beyond just the technical setup, what's the one non-technical skill that becomes mandatory in the cloud?
Cost control.
Ah.
Every line of code, every configuration choice, it has a dollar amount attached to it. Effective cloud architecture demands aggressive cost optimization. It's a financial skill just as much as it's a technical one.
Okay, so that really sets the foundation of our entire architecture. Now let's shift gears a bit into the specialized areas driving all the innovation right now, how we manage all this data and, integrate intelligence.
This is where things are moving fastest. We start with data engineering. This is all about taking raw, often chaotic streams of information and turning them into clean, reliable pipelines for analytics and AI.
So why is that pipeline now its own dedicated discipline? I mean, what's involved beyond just running some database queries?
It's the sheer volume and the complexity. We're talking about advanced data modeling, building data warehouses, orchestrating complex ETL or ELT processes. The transformation is where all the value is.
Taking messy data and making it useful.
Precisely.
And the source mentioned something specific. DBT-style workflows. For anyone listening, what is that and why does it matter now?
So DBT is data build tool, and the style means treating your SQL transformations like software code.
Okay, so version control testing.
Exactly. You version control it, you test it rigorously, you deploy it systematically. This gives you strong data governance and obsessive data quality, which is, well, it's absolutely paramount when you're feeding AI models.
And once that reliable data plumbing is in place, we can bring in the intelligence. This is the real cutting edge, AI engineering.
Yep. And this is explicitly about building and integrating AI directly into products that customers use.
It feels like this skill has just exploded in the last couple of years.
It really has. It's moved beyond just training models. Now it's about familiarity with LLMs, large language models, and using something called retrieval augmented generation, or RAG.
RAG, everyone is talking about that. Can you break down why it's so important? Connecting LLMs to internal company documents, right?
Right. It's vital because out-of-the-box LLMs are trained on public data.
Yeah.
And they will happily make things up. They hallucinate.
A big problem.
A huge problem. RG lets an engineer retrieve specific, trusted company data before generating a response. It drastically improves accuracy and reliability. You're basically extending the LM's brain with your own documents.
Which makes the whole system safer. And the roadmap specifically calls out evaluation and observability as crucial here.
Absolutely crucial. Because unlike normal software, which either works or it doesn't, AI output is probabilistic.
It's a best guess.
It's a best guess.
Yeah.
So you have to build systems that are continuously evaluated to make sure the outputs are accurate and measurable. Without that, you're just running a black box you can't trust.
And that leads us right into the production side of things, which is MLOps and model deployment. This is about the messy details of how these models actually run and get maintained in the real world.
MLOps is the skill that makes sure your AI works in the wild, not just in a notebook. It involves building, training, and serving pipelines, but also deals with what happens after deployment.
The source mentions two very specific terms here, feature stores and monitoring drift. Can you quickly define those for us?
Sure. Think of a feature store as a central library for the model's ingredients. the variables it uses to make a prediction. It makes sure the model sees the exact same data structure in training as it does in production. This gets rid of a huge source of errors.
Got it. So it's like a dedicated, reliable pantry for the AI. What about model drift?
Model drift is the slow decay of a model's performance because the real world changes.
Yeah.
Consumer behavior shifts, the market changes.
It's never static.
Never. So this skill requires you to continuously monitor for when the model's accuracy drops, which then triggers an automated retraining. It's lifecycle management for your AI.
Okay, we've covered strategy, architecture, and intelligence. But the best system in the world is useless if it can't run reliably and securely. That brings us to our final section, the operational and protection layers.
Right. Let's start with the automation engine, DevOps and automation.
This is all about keeping the system running smoothly.
Exactly. Streamlining deployment, monitoring maintenance, keeping the whole complex machine running.
We're talking about continuous everything here, right? The automation toolkit?
Correct. The source highlights CI/CD pipelines for rapid, reliable deployment. It mandates using Kubernetes for orchestration, and crucially, it talks about defining infrastructure as code.
What's the real benefit of defining infrastructure as code?
It means you manage your servers and networks using configuration files, not by clicking around in a console. So your infrastructure becomes version-controlled, repeatable, and easily recoverable. If you lose an entire data center, you can just recreate it by running a script.
That's essential for uptime. But operating safely is about more than that. It's about proactive security.
Absolutely. Which brings us to cybersecurity and zero trust. This adds the protection layer across everything we've built. And zero trust is the key philosophy here.
And that philosophy is?
You operate on the assumption that attackers are already inside your network. So no user, no system, inside or out, is automatically trusted.
That sounds solid, but with all the microservices we just talked about, how do you enforce that without slowing everything down to a crawl?
The roadmap focuses on a few key enforcement points. Robust identity and access management. Who can touch what is number one?
Makes sense.
Then strong encryption everywhere. Network segmentation to limit the blast radius of a breach. And, maybe most importantly, rigorous secrets management.
Passwords, API keys, tokens.
All of it. That has to be a critical, automated daily hygiene task.
So it's about micro-segmenting trust at every single API call. That is a massive layer. Okay, finally, we need all these separate systems to talk to each other to actually complete a business process.
And that's API and workflow automation. This is the glue. It's the integration layer that makes sure work can run reliably across different tools and teams.
And how does that work in practice? It's more than just a simple API call, right?
Oh, much more. It's about the intelligent use of webhooks, centralized schedulers, and powerful orchestrators. An orchestrator coordinates a complex, multi-step process across different microservices.
And it knows what to do if something fails.
Exactly. It knows how to retry or log the error or revert the whole change. It turns simple API calls into reliable end-to-end business workflows.
Wow, okay. That was a truly comprehensive run through all 10 skills. It all starts to click when you see them laid out not as a list, but as a stack.
It does. The source material has this visual of a funnel, and it really drives home the central idea. These skills are not isolated. They're synergistic. The output of data engineering feeds AI engineering, which gets deployed by MLOps. And the whole thing is secured by zero trust policies enforced through DevOps.
So what does this all mean for someone listening? What's the combined high-level value of mastering this stack in 2026?
The value, when you combine them, is that you can achieve three main outcomes. You can build smarter products, you can operate them safely, and you can scale them with confidence.
That confidence is the ultimate goal. As we wrap up this deep dive, let's leave you with a final thought. We've seen these skills stack vertically, from strategy up to security. But as AI starts to automate more of the routine tasks in, say, backend and DevOps, the real value might shift to the foundational skills, the ones that drive direction and safety.
That's a great point. Automation makes execution easier, but it doesn't make the decision-making easier.
Exactly. So consider this. Which foundational skill product and technical decision-making or system design mastery would give you the highest return on investment if you had to master it first? And more practically, where in this skill stack is your organization currently the most exposed? The stack is waiting for you to climb it.
Thank you for joining us for this deep dive into the essential tech skill roadmap.
We'll see you next time.